Memory and storage. Image acquisition. In digital forensics, it is important that investigators use special techniques to preserve the data they are analyzing. In a law enforcement setting, this is important because if the evidence was tampered with, then it may not be useful in a legal case against a criminal. In order to preserve the data on a device, it is a best practice to always make a copy of the data and then to analyze the copy. The process involved with this step will vary based on the type of device, type of data, and where it is located. In most cases, an image of the drive will be captured for further analysis. This image is the copy of the physical or logical drive which will be used during the investigation while the original hardware and data will be preserved. The most common type of image acquisition is called bitstream disk-to-image. This type of acquisition involves creating an exact replica or clone of the original drive. You will learn how to do this later with FTK Imager. Another method that is available is called bitstream disk-to-disk, which is used when it is not possible to create a clone of the drive using bitstream disk-to-image. This can be used to create an exact replica of the physical drive on a secondary external drive. For most cases, you will be using disk-to-image. Volatile versus non-volatile memory. Volatile memory, also referred to as short-term memory, fetches and stores data for immediate processes. This includes random access memory, RAM, and cache memory. Volatile memory is deleted automatically and usually is removed once the device is powered down. Non-volatile memory is permanent memory that is not automatically destroyed or removed when the system is powered down. It takes longer to fetch and store this type of memory, but it is more stable than volatile memory. Examples of non-volatile memory include USB drives and hard drives. Hard drive disk, HDD. HDD is a traditional storage device that uses a complex series of moving parts and is generally slower than a solid-state drive, SSD. In the early years of computers, hard disk drives were the standard for storage devices. However, solid-state drives are now becoming the new standard. Hard disk drives are mechanical devices that uses spinning platters and other parts to store, organize, and access data on the drive. Because of this, hard disk drives are much more fragile than solid-state drives and should be handled with care. Solid-state drive, SSD. SSD is a newer generation of storage device that offers more benefits than the older hard disk drives. Solid-state drives use a chip called NAND flash memory, which enhances the speed of the device. This is accomplished by not having moving parts like older hard disk drives. Solid-state drives work similar to random access memory, which is a form of short-term memory commonly used by computers. File systems. File allocation table. The file allocation table, FAT, is used by the operating system to find files on a disk. The FAT file system has been used since the inception of personal computers. It keeps track of all the pieces of a file, even though it is scattered around the disk through fragmentation. FAT does not offer any security protocols for protecting files on a computer. This means that anyone with access to the computer can access FAT files. Although there is no security, FAT does allow for quick and easy access to the files. FAT32. FAT32 is a more advanced version of the regular FAT file system that offers more flexibility and storage capacity. FAT32 can be used for drives that range from 512 megabytes to 2 terabytes. FAT32 allows for a larger number of bits used to address clusters of data, which means it has better storage efficiency, disk utilization, and speed than the regular FAT file system. NTFS file system. The New Technology File System, NTFS, is an enhanced file system that offers more security, storage space, and disk utilization. NTFS offers better security than FAT by allowing users to create assignable permissions for files and folders. Each file has an access control list at the local level and the network level. This allows users to be contained within the partitions that they are authorized to access. NTFS is also larger than the FAT file system with a maximum capacity of 16 exabytes, and NTFS also offers file compression up to 50% to maximize storage space. NTFS is also better for recovery protocols due to internal transaction logs, which automatically store data if power is lost or the system fails. exFAT file system. Extended File Allocation Table, exFAT, is a file system that was designed specifically for Microsoft Flash memory. exFAT also uses access control lists to monitor logs instead of clusters like the FAT32 file system. exFAT is not as widely adopted as FAT32 and NTFS. exFAT is considered a newer version of FAT32. In terms of functionality, it rests between FAT32 and NTFS. HFS Plus file system. HFS Plus, also referred to as macOS Extended, is a file system designed to work with a variety of storage devices to include optical disks. HFS Plus can naturally mount on Linux and Unix systems and can be configured to work with Windows with third-party software. HFS Plus prevents fragmentation by automatically searching for free space to accommodate the file. HFS Plus also supports access control, encryption, and file compression. Apple File System, AFPS. AFPS is a file system that was released by Apple in 2016 and offers some new features when compared to HFS and HFS Plus. AFPS takes advantage of solid-state drives, SSD, which is a newer form of storage that provides faster speed. Therefore, AFPS allows for better storage utilization, better performance, and less file corruption. AFPS also allows for more dynamic encryption to include single-key and multi-key options. Apple computers and iOS devices automatically use the AFPS file system. However, it must be stated that when formatting drives, AFPS is not compatible with Windows. Drives used with Windows or Linux systems should be formatted with exFAT or FAT32. Linux file systems. Extended File System 4. ext4 is the latest version of the extended file system, which was first developed in 1992. The extended file system has gone through several versions since it was first developed, with improvements with each version. ext4 extended the file storage limits from ext3 by expanding file limits up to 16 terabytes of data. Next, the exFS file system is a high-performance 64-bit journaling file system used to manage storage systems at scale. exFS was created in the 1990s by Silicon Graphics. exFS allows the user to write many files to the system at the same time. The journaled file system is another 64-bit journaling file system, which was developed by IBM as an enterprise-level file system. This file system maintains records of the changes in log files, which allow for a faster and more effective recovery of lost data.